Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3, Paper 3-1 for May, June 2024, and this is part 2 for questions 6 to 11. Question 6 is coming from numerical solutions, where we cannot solve the equations given using the usual algebraic methods. Okay. Part A, by sketching a suitable pair of graphs, show that the equation cosec a half of x is equal to e to the power of x minus 3 has exactly one root denoted by alpha in this interval here. So this actually means that when you draw the two graphs, maybe one is going like this and then another one like that, they meet at one point. Okay. So where they meet, that is actually the root of that given equation. Okay. So let's check. We can have a table of just maybe 3 coordinates. We can just use 3 coordinates. So let me draw a table here. Now I have x here. Then I can say y1, which is equal to, it can be 1 over sine of x over 2. Okay. Cosec is 1 over sine. Okay. And then the other one, maybe y2 is going to be equal to this other one here, the exponential. So e power x then minus 3. So the interval given here is 0 to pi over 3. So I can begin from 0. And then I can have, let's say, pi, divide it by 2. I can have pi over 2. And then the other one is, let's say, pi. Okay. Of course, when we put 0 here, sine of 0 is 0. So 1 over 0 is undefined. So here I will put undefined. Okay. Then sine of, when I put pi here, okay, sine of pi over 2 is 1. So 1 over 1, that one will give us a 1. Okay. I'm putting the simplest here. 0, e to the power of 0, it is going to be 1. Then 1 minus 3, we shall get negative 2 here. Okay. Now let's put these others and we see what we get. So we have 1 divided by 1 out of, then sine of 90 divided by 2, that one will give us 45. So sine of 45. This one will give us root 2, which is 1.41. Okay. 1.41 here. Then how about this other one here? When we put pi over 2 as an exponent of e then minus 3, what do we get? E then to the power of pi over 2. Then after that, minus 3. This one gives us 1.81. 1.81. So I'll just come to this one here and then I'll put pi, shift, and then this. So e power pi, then minus 3. That is 20.1. I can say 20.1. Now we can draw our axes here. We label them. This is the the y axis. And then here we shall have 0. Then this is the x axis. So we have put pi 0, then pi over 2, and then pi. So I can put here pi over 2, and then this one is pi, something like that. You don't need many values. And then we have this one as a negative. Let's say the negative 2 is this other side. It is just a sketch, so you don't need perfect scale. Okay. Then we have this one, which is infinity, means that that line is asymptote to the curve. So that is the line which is not crossed by the curve. It is called an asymptote. An asymptote. Okay, so x is equal to 0 is actually this y-axis. Okay, so the curve then has to come like that, okay, appearing to be meeting y-axis at infinity. Now we have, for pi over 2, maybe this one is 1. Then 1.4 is maybe there. And then for pi is around there. So I'm going to draw a curve. So I'll assume that is the 1.14, and then this is the 1. Okay, 1.41 and then 1. Then how about this one here? It is beginning from negative 2. So this point must be shown. Okay. Negative 2, and then for pi over 2, It is 1.81, so it has to be above this one here. So for it will go like that. So meaning, I'll say this is y, which is equal to e to the power of x minus 3. And then this is y, which is equal to cosec of x over 2, like that. So since they are meeting at one point, then that one is the root. So they said that has exactly one root. So the point of intersection is, it is just 1 point. So that means indeed the root is 1. Okay. So that is that. Let me put off this. Let's go to part B. Verify by calculation that alpha lies between 1 and 2. Now, if I have a graph like this, which is crossing x-axis, this is the x-axis, and this is the root here. There is a value which is on its left, and there is a value which is on its right. Now, this value on its right corresponds to the y value that is below the x-axis. So because the y value is below the x-axis, y is a negative, okay? And then this one on the left corresponds to the y value that is above the x-axis, okay? So the y value there is positive. So meaning if we are having a root, we look at the value. If the root is in between two values, those two values must give different signs when we substitute in that function, okay? So this is what we are going to verify, okay? Now let's check this one here. Our function, remember, we are given this equation here. So you can take either this one this side or this one this side to get the function that you're going to use, okay? Let me take this one this other side. So I will have 1 over, cosec is 1 over sine, so I'll have 1 over sine of x over 2, and then I will subtract the e power x, then plus the 3, which is equal to what? 0. So meaning my f of x is going to be that 1 over sine of x over 2, then minus the e to the power of x, then plus 3, which is equal to 0. Then I can substitute in these values. So when I substitute when I substitute 1, what do I get? So 1 over sine of 1 over 2. And where you see trigonometrical functions, in this, you put your calculator in radians, okay? Then plus 3, what do we get? And then also f of 2. Here, when we put in 1 over a sine of then 2 over 2 is of course 1, okay? So minus e, then to the power of 2 plus 3, what do we get? So we put in the calculator. 1 divided by mine. Now my calculator is in degrees, so I need to change it to radians. So I'll press shift, then mod. Radians is 4. Then I will come back here, 1 out of sine of 0.5. Okay. Then from there, I'll subtract e, then to the power of 1, and then plus 3. So what do we get? We get 2.36 to the rest of those figures. Okay, 2.3675. 2.3675. I'll end it there. There are more. And then how about when I put a 2? So here I have sine of 1, because 2 over 2 is 1. And then e here is squared. So we get a negative. Do you see that one is positive, the other one is a negative? So this is negative 3.200, negative 3.20066, okay? And the rest which are coming on. Then I can conclude, and I say that since there is a sign change, since there is a sign change between f of 1 and f of 2, comma, alpha lies, then you write the statement given here. Alpha lies between, because alpha is that root, 1 and 2. Part C, show that if a sequence of values in the interval 0 to pi given by the iterative formula, this one converges, then it converges to alpha. The only thing you're supposed to do here is rearrange to get the original function, actually the original equation. The original equation given, so just drop the ends which you are seeing here, okay? So we shall have x, which is equal to the natural log of cosec of x over 2, then plus 3, okay? To undo the logarithms, we get exponentials. So that means we shall have e to the power of x, then is equal to what is inside here, okay? Because we have that rule in logarithms that log of a power b is equal to c. That means a power c is equal to b, okay? A power c is equal to b. That means if this one is log base e, then it will be e power this x, then equal to whatever is inside here, okay? So we are going to have this one equivalent to cosec x over 2, then plus 3. But remember, we had this one, this other side. It is e to the power of x, then minus 3, which is equal to the cosec of x over 2. And you are done, okay? Alternatively, you can begin from this one, which was given, and then you get this, okay? Let me do it here. So alternatively, remember we are having cosec of x over 2, which is equal to e to the power of x minus 3. So we are, remember, you are supposed to make either this x the subject or this one the subject. But when you make any of them the subject of the formula, what you are going to get as an expression, one converges, the other one diverges. So usually the one that they give you here is the one that converges, okay? So on the look of things, it is this one which was made the subject of the formula. So if you bring the 3 here, it will then be cosec x over 2, then plus the 3, which is equal to the e power x. I say that in order to undo logarithms, you use exponentials. That means to undo exponentials, we use logarithms. So I can introduce natural log on both sides. Okay. Cosec over 2, then plus 3 here, then is equal to the natural log of e to the power of x. Automatically, this one will go down, and natural log of e is 1. So meaning we shall have natural log of cosec of x over 2 plus 3, which is equivalent to x. So either way, you get it. Part D. Use this iterative formula with an initial value of 1.4. Determine alpha correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Usually, in most cases, they don't give us the initial approximation. So since we found out that in part B, the root was in between 1 and 2. So what I always advise is that you get the average of the two values. So average of 1 and 2 is going to be 1.5. So you begin your approximation, the initial approximation, as that mid value, which is 1.5. Okay. Then after that you continue. But then here we are given the 1.4. So there is no need to say 1 plus 2, then divide by 2. Okay. So our initial approximation is 1.4. So I will say my x1 is equal to 1.4. And then my x2, I'm going to substitute in the iterative formula given here. So it is going to be x2, which is equal to the natural log here of cosec is 1 over sine. Okay, cosec is 1 over sine. Then that 1.4 divide by 2. And then from there, you add a 3. So what do we get? Okay, then the next one like that. So let's put this in the calculator. Remember, the calculator must be in radians. Calculator in radians. We have natural log of 1 out of sine. Then let me put 1 over. So this is 1.4. Then we divide by 2. Then close this bracket. Then come here plus a 3 like that. So what do we get? We have 1.5156. So I'll write 1.5156. Okay. And they said give the values to each iteration to 4 decimal places. So these are 4 decimal. Then x3, you don't need to disturb yourself again writing natural log of this. No. The moment you show the examiner that you have substituted here in the first one, the rest just write those values. Okay. So I'll just come back to my calculator here. Where there is this 1.4, I'm going to put this value here. Don't put answer, okay? Because I know it is on your calculator. Don't put answer. So I'll just come back here and then I put 1.5156. So that is 1.4940. 1.4940. Then which one is the next one? Now put 1.4940. That is 1.49779. 1.49779. So it has to be 78 to 4 decimal places. Okay. Then the next one, 1.4978. That is 1.4971. 1.4971. Then let's try another one here. 1.4971. We get 1.4972. 1.4972. When do you know to stop? When are you supposed to stop? What are you supposed to look at? And then you say, let me stop here. It has to be here. You look at the values. We are supposed to round off our answer to 2 decimal places. So when I round off this one to 2 decimal places, it is going to give me 1.49. But when I round this one off, it is going to give me 1.50. This one 1.50. This one 1.50. So if the 3 consecutive values give you the same answer rounded to the required degree of accuracy, then that means you stop there. Okay. You can get, actually, suppose I had not done this one and you have done these 2 here. Okay. And they are the ones that are giving you 1.50. This means that to prove that, because you can get these 2, but then the third one, you find that the answer it gives you is not the same as this when you round it to 2 decimal places. So you have to do a third one to confirm. Okay, so the third one just confirms. Okay, now in other words, when you find these 2 here that are giving the same value, okay, these are the minimum number of iterations you must do. The minimum has to be when you get 2 results that are giving that degree of accuracy they want, like these 2 decimal places. Okay, so the minimum has to be here. How many iterations have we done? 1, 2, 3, and 4. So for this one, the minimum is 4. Okay, so that is that. So meaning our alpha is going to be equal to, because it is alpha that we are looking for, 1.50 to 2 decimal places. Okay, as simple as that. Then part E, they are saying that state the minimum number of calculated iterations needed with this initial value to determine alpha correct to 2 decimal places. That is exactly what I've just said. It has to be 4. Okay, the minimum number of iterations is the one that gives you 2 values that are rounding your answer to the 2 decimal places they have given you, or to the required degree of accuracy. 2 values that are rounding to that. The third one is the one that confirms. So minimum number of iterations is 4 for this case. Question 7 part A. On a single argon diagram, sketch the loci given by the equations, these ones here, okay, where Z and W are complex numbers. So this one is coming from complex numbers. If you see the modular sign, okay, the modular signs on one side of the equation or inequality, you just know that that is a circle. Okay, let me show you where it comes from. If this is Z, then minus, let's say we have A plus BI here. Okay, this one here, and it's like this, then is equal to, let's say, R here. Okay, so Z here is, let Z be equal to X plus IY. Okay, it is a complex number, so we can have X plus YI, then minus A minus BI here, which is equal to R. So separate the real from the imaginary, that is X minus A, then plus, this will be Y minus the B, like that, I. And then, of course, modulus of a complex number, we are supposed to take the imaginary I mean the real square, then plus the imaginary part, also squared under the square root. Okay, we use Pythagoras theorem here because you can have something here. This is the complex number, and then here there is a change in y, and then here there is a change in x. So what is the length of this? So we get the change in x squared plus the change in y squared, then is equal to what is here squared. That is Pythagoras theorem. So therefore, we are going to have something like this, which is equal to r. Now, if I square both sides, it is going to be x minus a squared, then plus y minus b squared, which is equal to r squared. If you can remember very well in your pure mathematics 1 in AS, this is the general equation of the circle. You see that? That's the general equation of the circle. And then if you find the modular signs on both sides of the equation, then you know that that is a perpendicular bisector. What we get there is the perpendicular bisector of the line which is joining the two centers. So I have a center here, and then I have a center here. You get it? Then the perpendicular bisector is the one. The points that are lying on this line are equidistant, okay, from each of these points, the centers here. So let me also show you something here. So suppose we have, actually, let me just deal with this one that is here. W minus, you are supposed to create a negative, okay, just like the way I've had this one here. You must have Z, then minus a complex number here. So I already say create a negative. So W, then minus, I can put this 3 here. Of course, this one will be a minus. You see that? Now, after getting that one there, we shall have this one is a W, then minus, then we shall have minus 3 here, and then plus 4i. Okay, so that means this one is going to be a perpendicular bisector between the two centers, 3 and then negative 2. So we pick the center from here, and also here negative 3 and 4. Okay, that perpendicular bisector between those two centers. All right, now we need to sketch this one here. How are we going to sketch it? So let me extend these ones. They are not even needed anywhere. Okay, these ones are not needed anywhere. So let me just rub everything off. But the point to take home is that if the modular signs are on one side of the equation, that is a center. So you subtract this from the z. You put a minus, create the brackets, but you must not change the meaning here. So if this one is a minus, then I'll put it here inside as a positive one, so that when you open it doesn't change. And then this one, which is positive, I must put a minus, just like that. Okay. All right. Now for this one here, let me repeat everything very neatly. So this will be z minus, and then we have 3 minus 2i. Then this one is equal to 2. So this is a circle. This is a circle of radius. The radius is the one that you are having there, of radius 2 and center 3, negative 2. Okay, then where we have this one, W minus 3 minus, then 2i, then is equal to W, then minus, I'm going to have also minus here, then minus 3 plus 4i, like that. So we are looking at a perpendicular. Remember, a locus of points, the points can lie on a straight line or they can be on a curve. Okay, then so this is the perpendicular bisector, of a line joining centers. The centers we have are 3, then negative 2, and then the other one is negative 3 and then 4. You see that? All right. Now, what will be, first of all, the gradient between these 2 points what will be the gradient? So the gradient is going to be 4 minus minus 2, then over negative 3 minus 3. This one will give us a 6 up here, then divide by negative 6, that will be a negative 1. Then that means that gradient of the bisector, is going to be negative 1 over this negative 1. You know, for lines which are perpendicular, m1 times m2 is equal to negative 1. So this one will give us a 1. Okay, and you know that a perpendicular bisector passes through the midpoint of a line segment. You get that? Now, if we get the midpoint of a line segment, these two centers we are having, what will be the midpoint? The midpoint, you know, it is the average of the x and then the average of the y coordinates. So 3 plus negative 3, that one will give you a 0. Then divide by 2, so that will be a 0. And then negative 2 plus 4, you will get a 2. 2 divided by 2, you get a 1. So that is the midpoint. Now let's sketch something here. Then we can now put, this is real. Okay, this is real of z, and then this is the imaginary of z. Okay, now we are going to be so perfect, okay, to avoid drawing potatoes, circles that are looking like potatoes, or what, you need to use a ruler. You get your ruler, and then you jot those points where they are lying. Okay, so this is 0. I can get my ruler here. Try to be neat in your work. Okay, so I can put maybe this one here, if in the middle there. Okay, just like that. Then I mark the points. So this is 1 here. This is 2, 3. You also do the same on the y. So where is our circle? The circle here is of center 3, negative 2. So 3 is here, negative 2 is down here. Okay, probably is here. Okay, that is the one. Then I bring my compass here. Okay, when I bring the compass, you stretch it to 2 centimeters. Okay, but mine, you can see that it doesn't go up to 2 centimeters. It ends at 3.4. So I'm just going to stretch it up to 4. Okay, then after drawing that circle, I'm going to reduce it. Okay, so I put it there, and then I draw my circle. Now when you draw your circle, since the radius is 2 centimeters, this center here is 2 units from here. That means it must touch this point here. This one has to be a tangent. Okay, then stretch here 2 units. It must be passing here, and then here, and then here. Okay, so this line here is a tangent. This one is a tangent to that circle. This one is a tangent, and this one is a tangent to that circle. You see that? So what I'm going to do is to reduce this one, because I cannot have something small here. So what I can do, I'll just reduce this one here, and then I try to reshape it here. Again, it is not yet. It should not protrude through the x-axis. It is almost there. So I'll reduce a little smaller. So like that. So that is how your circle is supposed to look like. It is just touching here. It's a tangent, then here, and then here. Those are all tangents. So that is our circle. Then next, we are going to draw these 2 centers. We are supposed to also show them that we have plotted them. So there is 3, negative 2. So where is 3 here? And negative 2. It is actually this center which we are having here. Then there is negative 3, 4. Negative 3 and then 4. It is somewhere here. So you show that. Now we are supposed to draw a perpendicular bisector which passes through the midpoint is 0, 1. So 0, 1, which is here. So this is a line that is actually joining these 2 centers, but the perpendicular bisector is the one that is passing through here. Okay, so now we are going to draw the tangent. I mean, the gradient is 1. That means I can move a unit here and also a unit up here. You get it? I will have another point here. The change here is 1 over 1. Okay, so I go like that. 1 unit, 1 unit, 1, 1. Even this way, 1, 1. Then 1, 1. 1, 1. Like that. 1, 1. You see that? That is the one that is going to be my perpendicular bisector. Now, by drawing this one perfectly, it is going to be, it is passing through this negative one and then this one, so it goes like that. That's the perpendicular bisector. So I can extend it this other side like that. Okay, so that is our graph there. Then next, hence find the least value of this for points on these loci. Give your answer in an exact form. Now Z, for Z, Z is the locus of points that are lying on this circumference of this circle, which are exactly 2 units from this center. Okay, so the Z values are on the circumference, and then the W values are on this perpendicular bisector. They are on that perpendicular bisector. The Z values, since they are on the circumference of this circle here, that means we are going to consider the shortest. Look at from the circumference, maybe here, you check with this, with that. All of these ones are going to be bigger. So our value that we are looking for is this one, from this point here to this point here. Okay, now this is what I'm going to do here. I'm going to connect this one here just like this, and then here. So these are 2 points here, then plus a point here. Those are 3. You see that? And then here, these are also 3 points. You can see that this is 3. So these are 3 points here. So I can use Pythagoras theorem to find this length here. But you know that the radius of this circle is 2 units. So after finding the hypotenuse here, then I will subtract these 2 here to get this h that I've put here. Okay, so we are going to have our triangle here. This triangle has a 3 here, a 3 here. So I need a something here. Okay, so that y using Pythagoras theorem is going to be 3 squared, then plus 3 squared. That is root of what? 18. Root of 18. 18 is 9. In fact, this is like 9 times 2. So square root of that, that is 3, then root 2. So I can write it as 3 root of 2. 3 root 2. Now, remember, this is 2 units from here, from the circumference to the center. So meaning the least value of this one here, the minimum, I can call it the minimum value, is going to be that 3 root 2 we have gotten, then we subtract the 2, and that is going to be our answer. Question 8. Use the substitution u is equal to 1 minus sine x to find the exact value of this one. Give your answer in the form a plus b root 2, where a and b are rational numbers to be determined. A rational number is the one that can be written as a fraction. Okay, so this is integration by substitution. We shall say u, which is equal to 1 minus sine of x. Since the variable has changed, that means we need to find the dx in terms of du. So what is du dx? Of course, when you differentiate a negative, a constant, it goes. Now, differentiate sine, you get cosine. But since there is a minus, this will be negative cosine of x. So making dx the subject to the formula, it will be negative du over the cosine of x. Okay? Then after that, from here, since I have sine somewhere, I can say sine of x is going to be equal to 1 minus u. Take this one, the sine this way, take the u here. Okay? Then after that, we can now also change the limits because it is going to be in terms of u. So if x is equal to pi, this lower limit here, what will be our u? So u is going to be 1, then minus sine of pi. Sine of pi is 0, so meaning we shall get this as a 1. If x is equal to 3 pi over 2, which is 270, so u is going to be 1 minus sine of 270 is negative 1. So 1 minus minus 1, that one will give us a 2. Okay. Then next, let us now express what we are given here. The integral 3 over 2 pi, then pi here, we have sine 2x, then we divide by the square root of 1 minus sine of x with respect to x. This one will give us the integral from 1 to 2. The limits have changed. Sine 2x is the same as 2 sine x, the cosine of x, okay, the double angle for sine. Then we divide by square root is the same as power half. So 1 minus sine is actually the u. That means down here I can have u power half. Then now what is our dx? Our dx is this one here. So I will say times negative du out of the cosine of x. Now, do you see that the cosine of x is actually dying with this one? Okay, then next, we are going to have this 2 here. Let me take the 2 outside. 1, then 2, and then sine of x here is this one. I made it a subject, is 1 minus u. Okay, so I'll write 1, then minus u out of u to the power of a half. Okay, then actually I will take this negative also outside here, then du. Okay, now let's look at what we are having here simplified. This is negative 2, then 1 to 2. Whatever is in the numerator has this denominator here. So we shall have 1 over u power half, and then u over u power half. Of course, using the rules of indices, this one will be u power negative a half. Take this one up here, it will be 1 minus a half, and that will be u power a half. You see that? So I will have here my u power negative a half, then minus u power a half with respect to u. Now, when we integrate, we increase the power by 1 and we divide by the new power. Negative a half plus 1, it gives us a half. You see that? So we shall have u power half here, divide by that a half, minus u power half plus 1, that will be 3 over 2. Then we also put this 3 over 2 down here. And then the limits 2, 1. Some of you, after integrating here, you still bring back the integral sign. Don't bring back this integral sign if you have integrated. Okay? You just put the limits just up here. Like that. One up and then the one down. Then this one can go, simplifying this one can somersault. So the 2 can go up. We shall have 2 u power half minus 2 over 3 u power 3 over 2. Then put a 2 and then 1. Now let us put the limits. So when you put 2, you will have 2, then 2 power half minus 2 over 3, then 2 power 3 over 2. Okay. Then subtract, put 1, it will be 2, then minus 2 over 3. Okay. Now let's simplify this one here. 2 power 1, then times 2 power half, that is 2 power. This one is going to be 2 power 3 over 2. But also here we have 2, okay, over 3. Then there is also 2 power 3 over 2. This one I'm going to leave it because there is something common, okay. Then of course minus 2 times 3. 2 times 3, you get 6, minus 2, you get 4. So meaning what we shall have here is minus 4 over 3, like that. Now, this is negative 2 into this one is common, the 2 power 3 over 2, okay? So the coefficient here is a 1. So now 1 minus 2 over 3, this will be 3 minus 2, that will be a third, okay? So I'm going to write a third here, a third, of 2 to the power of 3 over 2. Okay, then minus 4 over 3. Now, I can actually take a third because it is common here and here. I can take it out. And then I have, this will be a third. But let's look at what we are given here to show. It is a plus b root of 2. A plus b root of 2. Okay. Now, simplifying this one here is going to give us, this is negative 2. In fact, let's get negative 2 and we multiply it all through. Okay, so negative 2 times a third times 2 power 3 over 2, then minus 4 over 3. You also multiply it by negative 2. All right. Now, this one is a positive one, 8 over 3. So I'm going to have 8 over 3. Let me write it first. Then minus, this one here is going to be a third of then 2. You get this one plus this, plus the 1. So you will get 5 over 2. So I can have 5 over 2. Now, this one here, I can write it as 2 power 2 times 2 power half. Okay, because you have this 2 plus the half. That is the 2.5 you have here. You get it? So 2 power 2 and then that a half. Then we are going to have this 3 down here. So this is 4 over 3, then square root of 2. You see? So I'm going to have 8 over 3 minus, this will be 4 over 3, then square root of 2. Okay? So that will be our answer there. Remember, they said that A here and B are rational numbers to be determined. So our A is 8 over 3, and then our B is negative 4 over 3. So that is that. Question 9 is from vectors. The equations of two straight lines L1 and L2 are these ones here, where A is a constant. The lines L1 and L2 are perpendicular, show that A is equal to 4. So for two perpendicular lines, that means the scalar product of the directional vectors is 0. Scalar product, or the dot product of directional vectors, of their directional vectors, must be equal to 0. So the directional vector of L1 is this one here. I can call it maybe D1. That one is 2, negative 1, and A. And then D2 is going to be 3, negative 2, negative 2, which is coming from here. It's the one you see in the brackets. Okay, so let's get the dot product. So this is 2, negative 1, and A. Then dot it with 3, negative 2, negative 2, and then you equate to 0. So we shall have 2 times 3, then plus negative 1 times negative 2, and then plus A times negative 2. We shall equate this one to 0. So this will be 6, then plus 2 minus 2A is equal to 0. So this will be 8, which is equal to the 2A, and then when you divide all through by 2, A becomes a 4. Then next, they are saying that the lines L1 and L2 intersect. Find the position vector of the point of intersection. So I'm going to express all of these in the, what we call the parametric equation. So for intersection, our R1 must be equal to R2. Okay. Now, let's go back up here. We are given this one as our R1 and this one as our R2. So I will have the x coordinate here parametrically. It is going to be 1 here, then plus 2i. So 1 plus 2 lambda. Then here we have negative 2, and then here there is minus lambda. And then the z will be the 3 from the k, and then lambda here times the a. So a lambda. Okay. So that's what I'm going to write down here. So I will have 1 plus 2 lambda, then negative 2 minus lambda, and then 3 plus 4 lambda. Okay. Then this one, already my A, I've gotten it as a 4. Okay. So that's why I'm putting here 4 lambda. then this one here is equivalent to, for this other one here, that is -1, then plus mu, -1 minus 2 mu, and then -1 minus 2 mu. Okay, we shall have -1 plus 3 mu, then -1 minus 2 mu, and then lastly we have -1 minus 2 mu. Now, I can use any of the two equations that I can get from here to solve for lambda and then mu. But I can actually use these last two here. If I get -2 minus lambda, then 3 plus 4 lambda, this one is equal to 1 minus 2 mu, and then -1, it is also negative here. Then minus 2 mu. You can see that we can subtract here such that this one disappears. Okay, so when we subtract, this will be -2 minus 3, that will be -5. So we shall have -5. Then minus lambda, minus 4 lambda, that will be -5 lambda. Okay, so we shall get -5 lambda. Of course, this way we have 0. So meaning I will have -5, which is equal to 5 lambda when this one crosses the equal signs. So lambda is therefore going to be -1 when you divide all through by 5. After getting the value of lambda, I don't even need to find the value of mu. Okay, I don't need the value of mu because I can just use this one as my point of intersection. So that means point of intersection, which I can call OP, point of intersection here, is going to be equal to our OP, okay, which is going to be now 1, then plus 2 times -1, then -2 minus, then -1, and then 3 plus 4 times -1. So what do we get here altogether? We shall get a -1 here, and then here we shall actually get -2 plus 1, that one gives us -1, and then 3 minus 4, that one will give us a -1 also. So that is our position vector of the point of intersection, which you can also write as maybe -I minus j minus k, like that. This one is also another one. So either you write this or this one here, okay? The point A has position vector -5I, then plus j plus 9k. Show that A lines on L. Now, for a point to lie on a line, its coordinates must satisfy the equation of the line. Remember, we have 1 plus 2 lambda. Let's check again. For L1, because they are talking about L1, this is the one here. It is 1 plus 2 lambda, then -2 minus 2 lambda, and the rest. We actually wrote it down here. It is this one here, okay? So I'll shift this and then put it the other side. So 1 plus 2 lambda, then -2 minus lambda, and then I have 3 plus 4 lambda, okay? Then I equate to this one. Since this is the position vector of the point that lies on that line, then that means the x coordinate here has to be equal to this -5. The y coordinate here has to be equal to the one that is here, okay? And then the z coordinate has to be equal to this -9. Now let's check. If we use this 1 plus 2 lambda, which is equal to -5, what is the value of lambda? It is going to be -5 minus 1, which is -6, then divide by 2. Lambda is going to be equal to -3. Okay, is it going to be the same lambda we get when we substitute here? I mean, when we solve this one here and also we solve this one here, is it going to be the same? Let's check. -2 minus lambda is equal to 1. So I will have -2, make this one cross here, and then it will be a -1. Then let lambda go the other side, then it will be a positive lambda. So again, lambda here is -3. You see that? Then we can also check the other one, 3 plus 4 lambda, which is equal to -9. Take this 3 here. You will get a negative. So -9 minus 3. Okay, and then lambda here is going to be -9 minus 3, that is -12. Then divide by 4, you'll get a -3. So all of them are giving us the same value of lambda. So that means that A lies So you just say, I can just conclude here that since lambda is the same all throughout, okay, all throughout, then A lies on L1. Okay, as simple as that. Then next they are saying point B is the image of A after a reflection in the line L2. Find the position vector of B as our part C. Now, I'm going to have, let's say this is the line L2, okay? And then I have a point here, then there is that line there. If this is part A here, I mean point A, which is actually -5, we have seen up there, 1, then -9. And then the reflection in here, this distance here must be equal, okay? So the object and the image must be equidistant from the middle line. So if this is, let's say, point B, which is x, y, z, we need to find the coordinates of this. That is the position vector of that B, okay? So here where they are meeting, already we have seen that the point of intersection of L1 and L2, okay, is -1, -1, -1. The other position vector we got, this one here, okay, this one here. So -1, -1, -1. This is the point of intersection between those two lines because they are intersecting. And they also said that these two lines are perpendicular. Check it here. The lines are perpendicular. Then part A, part B, part C, they are all under this stem here. Okay, so they are perpendicular. So that is our P. So when I go back here, my P is this one here, which is actually the midpoint of this line AB. It is the midpoint of this line connecting A and what? And B. So that means for me to get this one, I'm going to use the principle of finding what? Midpoints. So meaning -5 plus x. Then when I divide by 2, like I'm finding the midpoint of A and B, okay? So I'll get -5 plus this x, then I divide by 2, then I will equate to this x coordinate here, which is a -1, okay? Now, let us solve for this one. This is -5 plus x, which is equal to -2, and then x becomes -2 plus the 5, which is actually 3. So that is the x coordinate. How about the y coordinate? We shall get 1, which is here, then plus the y, we divide by 2, then we equate to -1. So 1 plus y over 2 is equal to -1. Cross multiply. 1 plus y is equal to -2, and therefore y is equal to -2 minus 1. So y becomes a -3. Okay? Then next we go to the z value. That is -9 plus z. Then we divide by 2. We shall also equate to -1, which is here. So making z the subject, we shall have -9 plus the z, which is equal to -2. So meaning z is going to be equal to -2, then plus 9. So z is going to be a 7. Okay. So meaning the coordinates, they told us to find a position vector of B. So then I'll write it as OB, okay, is going to be 3, that is for x, I can say 3i, then minus 3j, that is for y, and then plus 7k, just like that. Question 10, part A, given that 2x is equal to tan y, show that dy dx is equal to 2 over 1 plus 4x squared. Okay, now we are supposed to differentiate here, and then we make dy dx the subject of the formula. So this is implicit. I can actually say, maybe you take this, differentiate this one with respect to x, differentiate the 2x with respect to x. Then you also differentiate this one with respect to what? To x. It's like I've done nothing because this one can cancel with that. Okay. Now, because this is implicit differentiation, y is a variable, I'm going to first differentiate this one here with respect to y. Differentiate tan y with respect to y. Then after that, multiply with dy dx. Okay? I'll multiply by dy dx, because this one would have gone away, and then I have differentiating tan y with respect to x. You see that? So for implicit differentiation, that is what we do. So here I'll get a 2. When we differentiate tan y, we get sec squared. So we shall have sec squared y, then times dy dx. You see that? Now making dy dx the subject of the formula, of course, this one we shall divide it all through. So meaning our dy dx is going to be equal to 2 over sec squared y. But we also know that sec squared an angle is equal to 1 plus tan squared that angle. Okay, so I will have my dy dx here, which is equal to 2 out of sec squared tan y is 2x. So meaning tan squared y will be the 2x here, then you square it. So finally, we get our dy dx as 2 out of 1 plus 4x squared. Just like that. Then they are telling us part B, hence, meaning begin from where you have stopped or find a way of applying what you have gotten into this integral. Okay, so what are we going to have here? This is a product of two functions. When we are integrating a product of two functions, we use integration by parts. And in integration by parts, I've always told people that you use this acronym. One function has to be differentiated, the other one has to be integrated. So how do you know that this one is supposed to be differentiated and the other integrated? You use isolate. Okay, isolate, where I represents inverse trigonometric functions. Inverse trigonometric functions. Okay, then L is logarithmic functions. Okay, then A is algebraic functions, and then T here is for trigonometric functions. Don't confuse these two. This is inverse trigonometric functions. This is just trigonometric functions that don't have the inverse. Okay, then this one here is exponential functions. Now in here we are having algebraic, so it is here, and then inverse, which is here. So which of these two comes first? It is inverse. So the one which comes first is the one you differentiate. So that means I'm going to let my u now is going to be equal to the arctan of this 2x. Okay, and then my dv dx is going to be this other x that we are remaining with. Now take this one this side, I can have tan of u, which is equivalent to 2x. Okay, when you differentiate, this one will be equal to, already we have had something here, 2x is equal to tan y. That means dy dx is this one here. Okay, now let's try to copy a leaf and then we write something here. So du dx, remember the other one was tan y is equal to 2x. Then they said dy dx is equal to the 2 over 1 plus 4x squared. Now tan u, this is tan y. You see that? So that means du dx is going to be equal to 2 over 1 plus 4x squared. Hence, so you have to see something that is similar. And then of course v here will be the integral of this x here. It will give you x squared over 2. Okay, so for integration by parts, we have the integral of u dv dx with respect to x is going to be equal to uv minus the integral of v du dx, then with respect to x. So that means when we are integrating this one here, a half, then root 3 over 2, and then x, then tan, the arctan of 2 of x with respect to x. This one will give us our u is, what is our u? Our u is the arctan, and then v is this one. So when I put them together, I will have x squared over 2, then times the arctan of 2 of x. Okay, then after that, I will subtract the integral. Our v is x squared over 2. Then du dx is this one here. So substitute and you put 2 over 1 plus 4x squared. Okay, then dx. Now, in fact, let me just put these limits just up here. I mean, on these brackets here. So we have here a half. Now, what do we get here? We are going to have, this is x squared over 2, then turn the arctan of this, then minus, of course, this one will go. Okay. Now, when that one goes, we shall have an integral here of x squared over 1 plus 4x squared here, then dx. Okay. Now, how do we go about this one here? If we had something like x up here or 2x just without a square, we would look at the derivative of this one, which will give us like 8x. Then we ask ourselves, what should we do to the 8x here in order to get, let's say, the x that is up here? Okay, it will be divided by 8. So we would write 1 over 8, then the natural log of what is down here. Okay, we would write that. But we are not going to write that because when you differentiate what is in the denominator, you don't get exactly what is in the numerator. You see that? So that one there has to be dealt with a different way. Now here we are going to use partial fractions, where first you can see that what we are having here, the power of this one, the degree of the numerator is the same as the degree of the denominator. So meaning I can first use long division to simplify this one here. Okay, let us use long division to simplify what we are having here. So we have the divisor as 1. It is actually 4x squared plus 1. I can write it like that. And then the dividend is x squared. So x squared divided by 4x squared, you will get 1 over 4. X squared divided by 4x squared. This one will cancel. So you get 1 over 4. Okay. So I'll write up here a 1 over 4. Then after that, now I can multiply through. You just divide the first and then you multiply all through. So when we multiply this with this, automatically we get x squared. And then 1 times a quarter, you get a quarter. Okay, so plus a quarter. Then when we subtract, we shall get negative a quarter here because there is a 0 here, now minus a quarter. Okay, then after that, that means the integral of this x squared here over 1 plus 4x squared with respect to x is going to give us the integral of 1 over 4. Okay, then minus or plus the remainder. So minus a quarter of 1 plus 4x squared here. Okay, this is what we are having here with respect to what? To x. Now we have, let me go now to the next page. So we have the integral of 1 over 4 minus 1 over 4 into 1 plus 4x squared. Okay, this one here with respect to x, automatically this one will give us a quarter x. So I will have a quarter of x, and then minus, I'm going to put this a quarter. In fact, on the previous page, I was having it just up here, but it's the same thing as writing it as 1, then you put the 4 multiplying with the denominator here. So I'm going to put it outside, and then I remain with something like this here. I will have here 4, 1, then plus the 4x squared. Now I have something, then plus the x squared, and then here I have a constant. That has to be an arctan. But for an arctan, we must have something has to be like this, 1 over s squared, then plus x squared dx. So, and then we say this is 1 over a, and then the arctan of, you can check in the list of formulae, it is always given, the arctan of x over a. But now, when you check this one, the coefficient of x squared is not 1. So what I need to do is to first factorize it out. So I will say 1 over, put out the 4. Okay. Then that means here I will have a quarter, then plus x squared, then dx. Because when you open here the brackets, 4 times a quarter, you will get this one here. And then 4 times this one, you get this. Okay. Now, what are we going to have next? Do you realize that this one here, the last one we are dealing with, I'll take this a quarter outside. So it will come here and multiply with this. Do you realize that this is the same as a half squared, then plus x squared? So isn't it in this format here? It is in that format. So that means we shall have 1 over 4 of x, then minus. This one is going to be 1 over 16, then times. Remember, we are supposed to put 1 over a. So it is going to be 1 over 2. You see that? That is our a here. Then the arctan of then x over a. The a is a half. So meaning we are going to have a quarter of x here, then a minus, of course this is a half, so 16 times a half, you will get 8. So we shall have 1 over 8, and then the arctan of, then this one will somersault, and then we'll multiply with that x up there. So meaning we shall have a 2x here. Okay. Now, what do we therefore have altogether? So the integral from a half root of 3 over 2, then x, the arctan of 2x here, dx. This one is going to be equal to, we have our v. Let me go back and pick this one here. Then the integral of this, we have seen it the other side. So x squared over 2, then arctan of 2x. We shall have x squared over 2, then the arctan of 2x, then minus 1 over 4 of x. Now, it is minus the whole of this, okay? So the signs are going to change. So we shall have this one as a plus 1 over 8, and then the arctan of 2 of x. Then we can now put the root of 3 over 2, and then a half. Now, let's put the limits. So our limits here, we are going to have root of 3 over 2, you square it, divide it by 2, then arctan of 2 times root of 3 over 2, minus, this is a quarter, times root of 3 over 2, then plus 1 over 8, then the arctan of 2 times root of 3 over 2. Then after that, we are going to subtract. Let us now put this a half. So we have a half squared, then divide by 2, and then the arctan of 2 times a half, okay, then minus a quarter times a half, then plus 1 over 8, then the arctan of 2 times a half, like that. Okay, now when we get this one squared, we shall have a 3. Okay, this one squared, we shall have 3 over 4, then times a half, okay, because there is this one down. So if I somersault it, it will be a half. So that means that is 3 over 8. Okay, so this one simplified, you can even just put it in your calculator. It is 3 over 8 times. Here where you are having an arctan involved, make sure that your calculator is in radians. Okay, now this one will cancel with that. So arctan of root 3, that is 60 degrees. So I'll write it here as pi over 3. Then minus, this will be root 3 over 8. Root 3 over 8. Then plus, this is 1 over 8 times arctan of root 3 is still, okay, is still pi over 3. And then what else? So that is what we are having here. Then subtract, come down here. 1 over 4 divide by 2, you get 1 over 8. And then arctan, now let me just simplify this also. 2 times a half, that is 1. Arctan is 45 degrees, which is pi over 4. Then minus, this will be 1 over 8. And then there is also plus here. Then pi, 1 over 8, then times pi over 4. So it is supposed to be like that. So we have pi here over 32. This is the one here. And then the next one, this negative is going to affect that one. So it will be a plus 1 over 8. And then a negative here, this one, it will make it a negative. So minus pi over 32. 1 over 8. Then plus 1 over 24. Then we also have 1 over 32. There is also minus 1 over 32. So that is 5 over 48. So I'll write this as 5 over 48 of pi. And then we have, of course, this one is alone. So I'll have plus 1 over 8. And then we have root 3 here over 8. So minus root 3 over 8. So this one here is going to be the exact answer that we are supposed to have there. Question 11. In a field, there are 300 plants of a certain species, all of which can be infected by a particular disease. At time t, after the first plant is infected, there are x infected plants. The rate of change of x is proportional to the product of the number of plants infected and the number of plants that are not yet infected. The variables x and t are treated as continuous, and it is given that dx dt is equal to 0.2 and x is equal to 1 when t is equal to 0. Part A. Show that x and t satisfy the differential equation 1495 dx dt is equal to x into 300 minus x. Okay, now in O level you did what we call variations. Okay, so they say this is the same thing here. They say that at time t, after the first plant is infected, there are x infected plants. The rate of change of x is proportional to the product of the number of plants infected. So this is what I'm going to write. I'll have dx dt, because we are these plants are being infected. Okay, so this one is proportional to the x, the number of plants that are infected, and the number of plants that are not yet infected. Okay, so if we begin with 300 plants, so at first we have x plants which are infected. That means the ones that are not infected are 300, then minus x. Okay, and then they said that it is a product. Okay, is proportional to the product, and product is multiplication. Now to remove the proportionality sign, I will put a constant. Which constant I have to find? So kx into 300 minus x. Okay, we are given that when x is equal to 1, t is equal to 0, then dx dt is equal to 0.2. These things are given here. Okay, now I substitute in here. These values given are the ones that are going to help me find the k. So I'll put 0.2, which is equal to k. The x is a 1. Then in here, 300 minus 1. So that is 299. So meaning k is going to be equal to 0.2 out of 299. So simplified, what can this give us? (0.2) divide by 299. 1 over 1495. Okay, so this is 1 out of 1495. So you can see that the 1495 they have told us to show in here is already there. Okay, now we can proceed to write dx dt. Okay, dx dt is equivalent to that k, which is 1495, then times x, then into 300 minus x. By cross multiplying here, we shall have 1495 dx dt, then which will be equal to x into 300 minus x. And this is what they have told us to find. Then part B, we are told to use partial fractions to solve the differential equation and obtain an expression for t in terms of a single logarithm involving x. Now here we need to separate the variables. We put x on one side and then the dt on one side. Okay, So we have separating variables here. And we are always using multiplication and division, okay, or cross multiplying. So when I cross multiply here, I can shift this one here and it comes down here, then take the dt this side, okay. So that means I'm going to have 1495 out of x into 300 minus x of dx, then this one is equal to dt. Then after this, we can integrate, because to undo the derivatives, you integrate. So integrating, we shall have 1495 out of x into 300 minus x dx, which is equal to the integral of dt, okay. Automatically, this one here will go to the one on the right, will go to a t. So when you integrate, I must have an x here, sorry. Here I have dx, and then here dx again. Now here we shall have a t, then plus the constant. We don't know the constant which disappeared when they differentiated, okay? So we need to put that c back. Now we need to reduce this one to partial fractions. So 1495 out of x into 300 minus x. This one, we have a linear factor here and another one here. That means we shall write a over x, then plus b out of the 300 minus x. And our mandate is to find the values of a and b, okay? So using this one as the LCM, so this one divide by x, you will get this one here, then times the a, okay? So that means we shall have a, then times the 300 minus x, then plus this LCM here, divide by this, that one will go, then we remain with this x here, now times the b. So that means we shall have b here times the x. So that means down here, I'm having that as the LCM, okay, like that. But then I don't need to waste my time writing this, because it is going to be the same as the one I write here and this one here. So I just multiply those ones there, plus bx, then I equate to the numerator 1495, just like that. We have a into 300 minus x, then plus b of x, which is equivalent to 1495. So you look for values of x that can terminate one of the terms here, and then you remain with the other. For example, if x is equal to 0, that means this one will go away. So I will remain with this one here. You get it? So that means I will have 300 of a, which is going to be equal to 1495. So therefore, what will be our a? Our a is going to be 1495 divided by the 300. Okay, can this one be simplified? Let's check and see. 1495 divided by 300. So this one will give us 299 over 60. 299 over 60. That is the value of a. Then suppose our x here is equivalent to 300. Okay, when I put 300 here, the whole of this is going to go. So that means we shall have 300 of b, which is equal to 1495. It is just the same thing as this one here. So that means b is also going to be equal to 299 over 60. Okay, having gotten those two values, this means that we shall have the integral of our a, which is 299 over 60, then divide by x, and then we shall have plus 299, okay, over 60. Then this one is out of 300 minus x, okay. All of this we are integrating with respect to x, but then this way we got a t, then plus c, okay. Now I can put this 299 out of 60 outside because it is common. Then I will have 1 over x, and then here I'll have 1 over 300 minus x, okay. Then dx, this one will be equal to t plus c. Now when I differentiate this x, I get the one that is here. So that means here I will have the natural log. So 299 over 60, then natural log of x here. And then here, when I differentiate this, I get -1. But up here, I'm having a 1. So what should I do to this -1 in order to get a 1? I'll multiply it by -1. So this operation that I've done here, it is the one that I put on the natural log. So that means this one will be minus the natural log of 300 minus the x. So this is what I'm going to have here. Then plus the t, this one will be equal to t plus c. I can simplify this one and I write it as a single logarithm. Then I'll have natural log of x out of 300 minus x, because you know that when logarithms to the same base are being subtracted, then we divide the powers. So that is t plus c. Okay, but then we were given here that when x is equal to 1, we were given something like this. When x is equal to 1, t is equal to 0. So I'm going to substitute it here also. When x is equal to 1, okay, t was equal to 0. So you put in here, you will have 299 over 60. Then natural log of 1 over 299, because 300 minus 1, that is 299. You get that? Then that will be the value of c. You see? Now, that means my differential equation here is going to be 299 out of 60 natural log of x out of 300 minus x, and then this one is equal to t, then plus 299 out of 60, then the natural log of 1 over 299. That's what we are having there. And remember, they told us to solve the differential equation, but then we find an expression for t in terms of a single logarithm involving x. Okay, so proceeding from here, we are going to make t the subject of the formula. So take this one, this side here, meaning our t is going to be equal to, actually 299 over 60 is common. So I will have here natural log of x over 300 minus x, okay, like that. Then I will subtract, because this one has crossed over, okay. I will subtract the natural log of 1 over 299, okay. And then here as a single logarithm, this will be 299 over 60. Then this is subtraction of logarithms, so we are supposed to divide the powers. This will be natural log of x out of 300 minus x. Then you divide by 1 over 299, like that. Okay. Then after that, of course, these are fractions, so I'll do the reciprocal of the denominator. So I'll have natural log of, this is x over 300 minus x, then times, this will be 299 over 1. So it will be like that. So meaning my answer is going to be 299 out of 60, then natural log of 299 of x, then we divide by 300 minus x. So that is our answer as a single logarithm. So this has been it for this part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.